The first presentation, that's Ólafur Ragnar Helgason. He's a Vice President of Engineering at OS. This is a cloud-based software company that offers a new way to experience TV and video over the internet. Ólafur has a PhD in electrical engineering from KTH, Stockholm, and over 15 years of experience in research in computer science and networking as a professional software developer. Please welcome Ólafur.
Good morning. I'm not wearing a tie. Thank you for the introduction. So today I'm going to tell you a story. I'm going to share some experiences on a technical journey that we have been on at OS for the last 6 to 12 months or so. And during this journey we've been rewriting, we've been refactoring, modifying and changing some of the core components of our platform and system. And sort of as a part of that, we have been experimenting and working with different technologies, different services, different paradigms for how you structure and build a backend system, and also different cloud hosting paradigms. And the purpose of this talk today is just to share some of the lessons that we've learned and the experience that we've gained. So even though I get the pleasure to be here today and present these findings, I just want to point out that this is of course not just work that has been done by me. I'm very fortunate and lucky to lead the team of some excellent, super talented engineers at OS. And this is basically some of the findings here today is of course joint work with all of them. So just to begin with, to reflect a little bit on the title of the talk, doing the things that you should never do. When I was preparing for this presentation, I suddenly remembered an old blog that I read long ago from Joel Spolsky, which some of you may know. He's a well-known blogger in the software industry and has been blogging on software for many years. And somewhere around 2000, he wrote a very interesting series, a blog series basically, which was called "Things You Should Never Do." And in the first post of the series, he says that you can maybe see this at the bottom if you have a good sight. It says that the single worst strategic mistake that any software company can make is to decide to rewrite the code from scratch. And we've been doing a lot of that. So that sort of frames a little bit the theme of my presentation, and I will try to reflect a little bit on our experiences regarding that. So to begin with, just to give you a little bit of a background, what is OS and what are we doing? So from a business level perspective, we are basically building a video channel platform for creators. And what are creators? We refer to creators and define creators as basically anyone who has a story to tell with a video format. And just to give you a few examples, I mean that could include something like a band, it could be a sports club, it could be an independent movie maker, it could be a production company that owns a catalog of video material. It could also be a traditional broadcast channel like the ones that we've been working with here in Iceland, the RÚV and the 365 channels. And basically, just as we say, anyone who has a story to tell and wants to communicate it with the world with the rest of the world through video on the internet. And what our platform provides for these creators is that they can upload and manage their videos on our system. They can create basically an internet TV station on our platform. So you can create your own live schedule. You can configure when shows are being aired, and there's some intelligence in that as well. You can configure VOD, basically the VOD catalog of your content, when which content is available and for how long and so on. You can specify geo restrictions on your content, which of your content is available in particular countries and which not, and so on. We also provide a subscription and a billing platform for the creators. So basically, all that they need to, basically they only need to have the video, and we have basically built a platform for them that takes care of basically all of the rest, and even subscription and billing. And we basically just do a simple revenue sharing. Our business model is basically a simple revenue sharing with our creators. So they are basically building subscription channels on our platform. And also, of course, and perhaps even most importantly, we also support all major mobile clients and big screen experience and so on. So this is basically the product that we're building and providing to the creators. Okay, so for some reason this doesn't work. But what this figure was supposed to show is that I just wanted to give you a sort of high-level overview of the technical platform that we have. So on the one hand, we have the creators that are uploading all the video to our site, and our platform basically consists of three main components. So the creators, they upload their video, and the raw video material is stored in our storage system, which is fronted by a CDN network to scale the distribution of the video itself. Then another big and important component that we have is our web services backend. And this is where all the business and application logic resides. So this is where we have a database, with all the users, all the channels in our system, all the meta information, the content information, all the videos that belongs to the channels, all the relations, so the subscriptions and billing and so on. So this is all in a backend system, and the interface that this system exposes to the clients, the mobile clients, the iPads, the telephones, the set-top boxes, and the software that we support. So the interface that the backend provides is basically a REST API. So it's based on web services and HTTP. And just to sort of give you, I want to start by giving you a short description of the sort of first incarnation of how we structured our backend system. So basically, this talk is going to be pretty technical. I will be digging fairly deep into some of the sort of backend issues that we've been dealing with, but most of the conclusions and the lessons that we've learned are still fairly general. Okay, so the first incarnation of our backend was built on this architecture, or principle of microservices. And what are microservices? So as I said, it's an architecture, it's a paradigm for how you structure a backend system. And the main sort of characteristic of this architecture is that you have many very small services. It's a sort of modularity. And each service is responsible for a particular function of the backend. And these services, they provide a well-defined interface either to the rest of the world or to talk with each other through, typically, or in our case, through a REST API and a message queue interface. Just to give you a few examples. So we had one service that was hosted, that was basically, let me back a little bit. So these services, a typical service is basically it's a web service, a piece of code that processes requests, HTTP requests, and each service also has its own database. Okay, and just to give you a few examples of these of the services in our system, for example, we had one service that was responsible for all the user information. We had another service that was responsible for all the channel and the channel schedule information. Third service in our system was responsible for all the meta information on the videos in the system. The name of the show, the actors, the description, PG rating, so on. So basically, this first incarnation of a backend consisted of something like 40 different services. Some of them were bigger than others, but there was somewhere between 40 and 50. And in our implementation, most of these services were implemented with Node.js. A few of them actually in Erlang, but the majority of them were implemented in Node.js with as the sort of runtime environment. And at the time when we started implementing this, we were really excited about this NoSQL movement and this NoSQL thing. And so we were sort of early adopters of the CouchDB database, and a lot of our services were actually using this database. They were connected through, they were communicating with each other either directly through the REST API or through our message queue, which we use as a backbone for messages and messaging and basically for events in the system. And we were hosting this at a cloud provider which is called Giant, which is similar to Amazon AWS. And the hosting method that we were using was the one that's referred to as infrastructure as a service. It basically means that what you get from your hosting provider is that you buy virtual machines. You buy a virtual machine with some memory, with some disk space, and with some I/O throughput, and you can buy these different types. You can beef them up even dynamically. But the thing is that, of course, you have to manage in order to install instantiate the services. You have to install the Node.js runtime. You have to install the CouchDB database. You have to install and configure any other services that you're using on these machines. And we've been running this system basically for around 2 years here in Iceland, with some success and also some issues, of course. But sort of as time grew, I think it's fair to say that the frustration in the sort of back-end engineering team was also growing with the system for many different reasons that I'll be going through now. And the first thing that I wanna mention is related to sort of deployment, how you deploy code on your backend. So we are doing continuous deployment, which basically means that we deploy to our backend system very often, sometimes many times a day. So we don't do basically big builds or anything like that, and deploy every 3 months where we do a major version upgrade or something. We are doing continuous deployment where we are constantly, every day, more or less, updating our backend. And one of the sort of, I guess it's fair to say, a little bit of a mistake that we did was that the sort of automation infrastructure and the sort of setting up the staging environment and all of this, it was sort of lagging a little bit behind, and we were a little bit slower on that than we should have been. And when you're doing microservices, the thing is that when you're running 40 services in comparison to a big monolith backend, the operational complexity increases significantly. You're managing a lot of virtual machines, a lot of processes on these machines. And if you don't have the automation infrastructure set up properly from the beginning, you will run into issues and problems, and it will slow you down significantly. And since we're running on an infrastructure as a service system, it means that you have to configure all the machines yourself. You have to learn, you have to use these automation tools like Chef or Puppet or whatever they're called. And you have to learn them, you have to be comfortable with them, and basically all of to implement continuous deployment successfully, all of your deployments have to be comfortable and be sort of pretty fluent at these tools. But the thing is that we are a company of software developers. We're not the sort of culture in the company is not really much focused on operations. So I would say we are major developers, but minor ops people. And all of this was basically, this was sort of one of the reasons for why frustration was sort of growing. And the sort of, one of the key lessons or sort of takeaway from this was that if you want to deploy some sort of microservices, but also, this is also just very important, of course, in general, is that you should try to automate everything from the beginning. Do not postpone it because you're in a rush, because then you're basically just increasing the pile of problems that you will have further down the road. Another lesson related to this is, and maybe more sort of more closely tied to microservices, is that it's very important that you use service discovery. Actually, this is a thing that we never really properly implemented in our system, but it will significantly make your life easier, because what service discovery does is that it basically removes a lot of the configuration headache that you have to deal with when you have different services running on different machines. And every time that you wanna migrate one service from one machine to another, you have to go and change a lot of configuration at different places, and this quickly becomes a significant headache. So if you use some sort of a service discovery mechanism where you can basically automate this, services will just query the service discovery mechanism. Where is this service that I need to talk to now? Then that is something that will make your life significantly more pleasant. And also, I will actually be coming back to this a little bit later. I can also say that one of the lessons that we have learned is that, and maybe this is well, you could call it a lesson, you could also just call it a personal opinion. I would say that you should not be using infrastructure as a service unless you have operations sort of culture in your company and people that are actually very interested in operations. More on that later. Another issue that was causing us a lot of headache with microservices is that, as I described here in the beginning when I was giving the examples of the services in our system, is that you are with microservices you are inherently splitting data between different services. As I said, you have your users on one service, we had our channel schedule on another one, and the content on a third one, and so on. And what you have to do when you're sort of specifying the service boundaries in the beginning is that you have to be very careful, and you have to think very deeply about how you will be using your data and how your data will be queried. And in a startup company where focus is maybe shifting regularly, let's say, this can be a little bit difficult to do. And it turns out that one of the problems that we were dealing with this microservices architecture is that sometimes we had requests from our users, and some of them just very common requests, like for example fetching the schedule of a channel. When you were fetching the schedule of a channel, you needed to query actually 3 or 4 other services. So obviously you need to have information on the user just to do authentication and see if the user has access to the channel. Then you would have to query the channel service to get the actual schedule. And then for each of the programs in the channel schedule, you would have to query the content service to get information on the title of the show, the poster, the actors, and so on. Because in the schedule view on our clients, we're showing this information as well. And this resulted in queries, or basically request times that were rather inefficient. And the solution that we did to sort of mitigate this is we were pre-computing in memory. We were basically pre-computing these requests or indexes in memory using tools like Redis, which is an in-memory database. So you would pre-compute them in memory, and then when the request comes, you don't have to do 3 requests on these different services. The request has already been computed, and you can give the reply straight away. But this means that the original data is, of course, originating, and the sort of source of truth for the data is in the original services, in the user service, in the channel service, and in the content service. So you're basically caching data all around. And okay, this gives you good performance, but it also significantly increases the complexity. We sort of felt that when we were working with this system, particularly those of us that are used to working with SQL databases, that we were doing a lot of work by hand that a more traditional sort of SQL-based solution could do for you in the database. And you could even say that basically what we were doing and what I've been describing here in some senses is that this is basically sharding of your data. What you do when your database becomes really large, then you have to split the data into different shards or something like that, just to cope with the scale. So in some sense, what we were doing here is premature sharding, and premature optimization is something that you should avoid. So if you're dealing, one lesson here is that if you're dealing with microservices, you have to select your service boundaries really carefully, and you have to know, you have to have a pretty good idea of how your data will be queried and used. Another lesson is that cache consistency is hard. So what is cache consistency? Cache consistency basically means that the data that you have in your cache reflects the data that you have in the original database. It means that if someone writes to the original database and updates your data there or deletes it or something, you have to be sure that these changes are propagated throughout the cache. Either you evict the cached object, or if it's an in-memory index, you have to update it there as well. And it turns out that cache consistency is harder to implement than one might think. And there was actually some famous researcher in computer science that there are only said that there are only two different problems in computer science: naming and cache consistency. And I guess there's a grain of truth in that. Moving on, just a few quick words on CouchDB and sort of this NoSQL thing. So CouchDB is a document store. It's a JSON. It's basically a JSON object store. So you store documents of pure JSON. So the idea is that it's quick and easy to use. You don't have to have any object relational mapping layer or anything. And I mean, we are working in Node.js and JavaScript, so you just directly basically write your JSON objects into database, and you can work with them. So you have a very thin layer between the database and the application. But it turns out, I'm not really going to go into the details of it, but it turns out that CouchDB has a very limited way of how you can query your data. You can build what they call views, where you build indexes based on some of the properties and the JSON objects in your document. But the thing is that these views are very expensive to update, and if you want to change a view that you've already created, it can take a long time to rebuild the view, which can basically mean that there's a downtime for your application. And to deal with, it's also difficult to query. In some cases, it can be difficult to query data and sort of relate data in one document to data in another document. And then we resort to denormalizing your data. So you basically you have one copy of the data here and another copy of the data in another document, and then you basically come back to this cache consistency problem. It's exactly the same problem. If you change the name in one document, and if it's denormalized in another one, you have to change it there as well, and this is a difficult problem. Another thing with CouchDB is that this was an open source project. It had a lot of momentum in the beginning, around 2 years ago, when we were sort of building the first incarnation of this backend. But this project sort of quickly lost momentum, and it never really lived up to the expectations that we had for it in the beginning. So the support and the tool set were still sort of limited, even today. So the conclusion and the lesson for this is, or basically what we've learned is that there is definitely a place for some of these NoSQL databases, particularly in when you're dealing with big data, and we are using some NoSQL databases when it comes to storing video and metadata on the video itself. But for the application logic in your system, it's much better to use a relational database if your data is inherently relational, sorry. Node.js, however, on the other hand, is a different story. We were also an early adopter of Node.js. When we adopted Node.js, it was probably more than 2 years ago now. It was really in its infancy. But similar to CouchDB, it was an exciting project. There was a lot of buzz around it. But unlike CouchDB, Node.js has really taken off on a large scale. So for those of you that don't know what Node.js is, it's basically just a JavaScript runtime. So you implement your backend services in JavaScript, and the runtime uses the Google V8 JavaScript engine, which is what runs in your Chrome browser. And this engine has basically been, it has been optimized to death. There's a great competition among all the browser manufacturers on JavaScript performance, and Node.js is really sort of benefiting on that. So you have a really powerful JavaScript engine, and then the other sort of key characteristic of Node.js is that all of the I/O operations that you do are asynchronous and non-blocking. And these two basically, so that means that you're basically never hanging on everything is single-threaded, but you're never hanging on a thread waiting for an I/O operation, disk read or a network operation to complete. And these two combined, the V8 runtime and this asynchronous programming model, gives you excellent performance. And the Node.js community is really active. There's a lot of code and packages available for the most obscure things. Some of them quality is of course pretty mixed, but the packaging system, the NPM packaging system, is pretty nice. And all in all, I would say we are pretty happy with our choice of Node.js. One thing is a little bit challenging, though. The asynchronous programming paradigm is a little bit different than what you're used to. If you're programming in Java or Python or most other languages. This paradigm of always providing a callback that will be invoked when your disk read operation completes can be a little bit difficult to sort of get used to, and it can be a little bit of a challenge to sort of structure your code well. There are well-known pitfalls that most developers step into initially when they start playing around with Node.js, which is called the callback hell. But there are libraries like Promises that we've been using with great success for the last months that make it much easier to deal with asynchronous programming. So all in all, Node.js kicks ass. Of course, it's not perfect. There's no silver bullet, but for our case, it has been. We've been. I guess it's fair to say that we've been pretty happy with it, and we're still using it. Also, one other thing, not very technical. So I'm sort of going through the reasons for why we have been migrating, why we decided to do the big rewrite, and sort of much of this architecture that I've been describing was created by some of the guys that were on the engineering team early on in the beginning, even 2 or 3 years ago, and most of the early architects have left us today, and as the sort of frustration with the backend system grew. You have this to deal with this sort of thing that it becomes a problem that the team doesn't feel sort of ownership for the code and the backend system itself, and this is very bad in a startup because if you join a startup you don't wanna have to dealing with legacy. So this is also one of the reasons for why one of the sort of non-technical reasons for why we decided to rewrite. And then also, as I said, we've been doing major requirements change on our business itself. We've been dropping features and significantly simplifying our model. So just to quickly summarize, where we are heading now is that we are still working with service-oriented architecture, but not sort of microservices. Still using Node.js, but we've gone on to using Postgres. And everything that we do today is on a platform as a service system, so we're running extensively on Heroku, which is significantly simplifying operations. And we're trying to optimize for speed so that we can focus on building OS and the sort of business logic in our system, but not spend time on configuring services or writing components that we do not have to deal with, that is not directly related to our business. So. That's a lesson. Use platform as a service if you can afford it, and if it makes sense for your business. And just to conclude quickly, I've already gone through all the lessons, and I'm not going to repeat them. So first of all, did a rewrite, did it take more time than planned? Well, of course it does. This is a sort of curse of the software industry, I guess. And the second question is then, is it already released? And no, it's not. But we're working on it. We're getting closer, and we're actually. I'm hoping that we will be releasing our beta to our first closed group of testers already today, or possibly right after the weekend. And then finally, coming back to the sort of initial question that was in the title, is rewriting software, is it the biggest mistake that a software company can do? And my answer to that is, you have to ask me in April. Because in April we will be launching our platform globally. So thank you for your time. For those of you that think this lecture has been interesting, I have one final message. Thank you very much.